guys, you're welcome to my channel once again, and this is Chemistry with CK. I teach chemistry for O-level, A-level, GCSE and WASSCE students. The last time we looked at half-life and how to calculate half-life. We saw that for us to calculate half-life, we have different formulas that we can use. But the simplest one to calculate the half-life is taking what? Natural log of n naught over n equal to kt. So we said that the natural log of the initial amount over the final amount equal to decay constant times t. So if you are able to find your decay constant, which is k, then half-life will be equal to into over k. Into here represents 0.693. So if we find our k from this expression, then we substitute our k in this equation 2, then we can find our half-life. So there are a series of exercises I've posted which you can try your hands on them, then we can deliberate on the answer. Today we are going to look at nuclear fission and nuclear fusion. Nuclear fission and nuclear fusion. Albert Einstein discovered one of the fascinating topics under radioactivity. Now, Albert Einstein saw that mostly when you have a heavy nuclei, it can split into two approximately equal parts, giving out energy and radiation. So we call this type of reaction occurring nuclear fission. So fission here means something splitting. In fact, a heavy nuclei splitting into two approximately equal fragments, releasing energy and radiation. For instance, when we have uranium-235 92, uranium-235 here can split to what we call barium-66. So what we are saying here is that there is a heavy nuclei here. And what are these heavy nuclei then? The heavy nuclei has splitted into two fragments. So the heavy nuclei, which is uranium-235, has splitted into two fragments. Two main fragments. So we have barium-56 and krypton-36. So when that happens, a heavy nucleus or a heavy nuclei splitting into two approximately equal fragments, at the same time releasing energy and radiation, is what we call nuclear fission. So So nuclear fission here, as we are saying, the splitting of a heavy atomic nuclei into two approximately equal what? Fragments with the release of what? Energy and radiation. So now, when you have a heavy nucleus, oh, these are heavy nucleus, and these are heavy nucleus is splitting into two approximately. We are not saying they have to be approximate, they have to be equal, but we are saying they are approximately equal. So now, this is a heavy nuclei, and this is the two fragments. Together with the release of energy and radiation. And that is what we call nuclear fission. Now, the example that I want you to know is uranium-235 splitting to give us barium, that's 141, and krypton-92. So as you can see here, uranium has been induced to split into two approximately equal ones with the release of our energy and what? Radiation. But we are saying that our focus is not on the energy, but the radiation rather. So as you can see, there has been a neutron which has been emitted. Now this neutron again can hit or can bombard krypton or can bombard barium to cause another breakage, and we call that chain reaction. But our focus here is on nuclear fission here, which we are saying that whenever you are having a heavy nucleus splitting to give us two approximately equal fragments with the release of energy and radiation, that is what we call nuclear fission. Now, nuclear fission means chemists or scientists splitting a heavy nucleus into two approximately equal fragments have a lot of advantage. And the energy that we get from this part here, the energy produced can also be used to generate electricity. So now, how do the energy produced here be used to generate electricity? Now, the energy produced here is used to what? Produce steam. And the steam produced is used to drive or turn turbines connected to a generator to produce what we call electricity. what we are saying is that now when a heavy nucleus splits into two approximately equal fragments, it releases energy. And this energy release is used to generate steam. And this steam generated or this steam produced will also use to drive or turn turbines, which is connected to a generator for us to get what? Electricity. So nuclear fission is used to generate what? Electricity. So, and with nuclear fission, the amount of energy produced is less as compared to what? Nuclear fusion. So when we say fission, that means that a heavy atomic nucleus is breaking down to two approximately equal fragments, releasing energy and radiation. So the energy released is used to produce electricity by converting this energy to steam and driving turbines of what? Generators. Okay, quickly let's look at what we call nuclear fusion. So as you can see from the name fusion, fusion means join. So what do we mean by nuclear fusion? So we are coming to join two lighter nuclei. What are we joining two lighter nuclei? We are joining two lighter nuclei to produce what? When we say nuclear fusion, here we are joining two lighter nuclei to produce what? Heavier one, with the release of what? Energy and radiation. So fusion is the opposite of fission. So when we say nuclear fusion, we are joining two lighter nuclei. Now the energy that is produced here is very high compared to that of fission. And this energy is very, very, very high and very, very high in amount. So quickly, let's look at what we are talking about. So the joining of two lighter nuclei to form a heavier one with the release of what? Energy and radiation. So for instance, we can join two deuterium particles to produce what? A helium-3 nuclei. What we are saying here is that we have joined two lighter nuclei. Here, the lighter nuclei we are talking about here, this is a deuterium, this is also a deuterium. Remember I told you that we have three types of isotopes of hydrogen, protium, deuterium, and what? Tritium. So when you join two deuterium particles or two deuterium nuclei, you produce a helium which is heavier. Then we release energy and what? Radiation. So we call this type of reaction nuclear fusion. Now what you have to know is that under fusion reaction, the energy which is produced is very, very high. It's higher as compared to what? Nuclear fission. So these two main reactions were discovered by Albert Einstein. And we saw that there are some reactions that we can cause it to be fusion and also some that can be fission. So when we talk about fission, we are splitting a heavy atomic nuclei. When we talk about fusion, you are joining two lighter nuclei. What you have to note here is that the energy which is produced in the fusion reaction is higher compared to the energy produced in the fusion reaction. Thank you. Let's continue. So, as we draw near the curtain of the topic, which we've learned a lot, we are to know some of the important or applications of radioactivity. So, after learning this topic or the products that are produced, what can we use them for? Now, under radioactivity, we have positive application and negative application, which we treat them all together. Now, what we are saying here is that one thing that we can do here is with radioactivity, we can use it in treating what? Cancer. So, for example, cobalt 60, which is a radioactive substance, is used in the treatment of what? Breast cancer and also cervical cancer. So, one of the important regrets is that we can use some of this radioactive substance to treat cancerous cells. Again, we also use it in what? In preserving or what? Sterilizing equipment. So, gamma rays can be used to sterilize equipment by killing bacteria, fungi, and also viruses. And because of that, there is an importance of them. So these radiations can be used also to sterilize equipment. Now you can understand, or some of you have heard about archaeological dating. Now with radioactivity, for example, carbon 14, we use in predicting the age of what? Old antiques or antiques. Old things. For example, as you have heard from the news, some people or scientists can tell us that, oh, this dry bones is 5,000 years. How do they do that? They use what we call carbon 14. So, applying the knowledge in radioactivity, we can also use in archaeological dating. We can also use radioactivity or radiations to determine leakages and cracks in pipes. So most of the story buildings, when there are blockages, we can apply some of this radiation to determine the point where these blockages are. Again, we can also use in making what we call atomic bombs. And remember that this is a negative impact. For example, uranium can be used to make atomic bombs, which causes more harm to the society. So, these are some of the applications of radioactivity. So what I want you to know is that with radioactivity, we have positive effects and we also have negative effects. And don't forget that when you are large exposed to this radiation, they can cause harmful effects such as bone cancer or blood cancer, which we call sometimes called leukemia. So what you are saying is that for you to know it, you should not be more exposed to this radiation. But there are positive effects which we are looking at, as well as what? Negative effects. But with application, we can apply all this knowledge here, and you should know that we can use it in treating cancerous cells, in sterilizing equipment, in archaeological dating, finding the ages of old antiques, determining leakages and pipes, as well as making atomic bombs. So as we draw the curtains to nuclear chemistry, you must know the difference between nuclear reactions and chemical reactions. As you can see, there are two main reactions that are written on the board. When it comes to chemistry, we call this a nuclear reaction. And we call this a chemical reaction. So there are two main differences. So when we are talking about this, how we write a nuclear reaction, and this is how we also write a chemical reaction. Now with these two, what is the difference? Now there are difference between the nuclear reaction and what? Chemical reaction, which we are going to look at. Now what you must know is that when we talk about nuclear reaction, what is it? It is occurring inside the nucleus. Generally, it occurs in the nucleus. But when we talk about a chemical reaction, it is occurring at the outermost shell. So, under chemical reaction, it occurs at the outermost shell. So, the nuclear reactions involve what? The nucleus. Here it involves protons, neutrons, and electrons. But when you come to chemical reaction, it only involves the valence electron. Again, with this, what does it form? It's going to form a new nuclide, or it forms new nuclei. But with a chemical reaction, what do they form? They form a new compound, Again, you've learned that nuclear reaction is affected by what? A neutron to proton ratio and what we call the decay or the decay constant. So it's affected by the neutron to proton ratio or the binding energy. So under nuclear reaction, it is affected by the neutron to proton ratio or the binding energy. But when you come under chemical reaction, it is affected by what? Temperature, pressure. So what you're saying is that when you change the pressure or the temperature, it won't affect any nuclear reaction. However, when you change the temperature and pressure, it is going to affect what? The chemical reaction. So chemical reactions are affected by what? Temperature, pressure, which we call external factors. But when you come to nuclear reactions, they are not affected by what? Temperature and pressure. However, nuclear reactions are affected by the binding energy or the neutron to proton ratio. So these are some of the differences between a nuclear reaction and a chemical reaction. So what I want you to know is, as a science student, as a chemistry student, you must know that this is a nuclear reaction, and you must know that this is a chemical reaction, and there are clear-cut differences between them. So with this brings us to the end of nuclear chemistry according to Ghana Education Service. We've just done a summary of it. Then we are going to move on to our next topic. Please don't forget to like, subscribe, and share. And always don't forget to tell a tired soul that there is God. Thank you and see you in our next topic. Bye bye.